All right, domain and range notation. Let's look at a problem. Let's say I have a graph that looks like this. Keep it real simple. And first thing I want you to answer for me or note is it continuous or is it discrete? Yeah, it is, right? Because it's a series of points that are connected, right? They're connected with a line. So this is continuous. And it starts for the domain. It starts where x equals what? 0. Good. So here's 0, and it ends when x is 4, right? Now, we're going to say that x, and we're going to put a funky sort of CE in there. It's element. This stands for element. X is an element. I'm going to put a bracket in that goes from 0 to 4. Now, the brackets have specific meaning. So this is saying the x, because it's the domain, x is the element between 0 and 4, as all elements, is basically what this is saying. These guys are including. The brackets include. We'll do another example here in a minute and show you what the difference is. So how about the range here? The range, what are the y values? Y is an element. Where do the y values start? 1, right? Good. And when do I run out of y values? Up at 3. Yeah, good. And are they included? Yes, because we have solid dots at the end of our lines. So I'm going from 1 to 3. The brackets include. Let's look at another continuous example. This is also continuous. Saying domain and range here is a little bit redundant because we have x and y. X is the domain, the number, or the x is in the set, and the y's in the set are the range. So we've got some redundance here. So this one I'm not going to say the same thing. I'm just going to say x is an element. Now, where does my x values start, or where do they start here? I've got an open circle here, but the open circle is above what value? -1, right. But that means it doesn't include the -1, but it would include any number greater than -1. So like negative 0.999 is included, but negative 1 is not. That's what the circle indicates. So this is not included. And the domain goes to 3. So here's how I do the not included. Instead of using a bracket, I use a parenthesis. So X is an element of the set starting at negative 1 but not including and it goes to 3. Do I include the 3 with the bracket or not? It's included, right. It's a dot it's a dot that's filled in. How would I do y in this case? How many values of the range are there? 1, right. There's only one. It's a horizontal line. All the y values on this line are 1. So since I only have one value, I would just say y equals 1. Okay. I wouldn't say that y is an element of the set of 1, although I think you could. You probably could do something like this. But I think this actually makes more sense. Y equals 1. So is everybody clear on the included and not included? That's your open circle and your closed circle or closed dot. Everybody okay with that? An answer would be appreciated here. Yes, okay, thank you. Excellent. All right, what about discrete though? Discrete sets we would answer a little bit differently. So we could have a graph where the points are individually on the graph, maybe something like this. Assume that my drawing is perfect. I know it's not. So for this we would say X is an element, and we use ellipses to define discrete. And we have to list all of the X values. So X is 0, X is 1, but not the numbers in between them. X is 2, X is 3, so we would list all of those. And we close the set with our ellipses thingies. All values are noted. And y is an element of the set. What y values do we have? 0, 1, 2, and 3. Yeah, it's the same set. Okay. How many numbers are represented in this continuous graph? these values, because you can continually cut something into smaller and smaller chunks. And points are infinitesimally small. When you put enough of them together, it makes a line, but you think of a line as an infinite number of points. It doesn't matter how long the line is. It could be long or short. There are many different ideas of infinity. It kind of gets back to that idea that I've addressed a few times of closing the distance between me and the door, but I can only half the distance every time. How many times do I half the distance before I get to the door? Never, or an infinite number of times, right? I can never get there. So, same thing here. How many numbers are there between there? You tell me how many there are, and I can double it because I can half those values. So, there's an infinity in any continuous situation.